Now, here's ethanoic acid or acetic acid, loses hydrogen for hydronium ions. These guys are often used. The products of them are salts, and they will be used as preservatives. So here are two reactions. We have methanoic acid and benzoic acid. Note that they lose this hydrogen, and the sodium from the sodium hydroxide replaces the hydrogen, right? We take the OH from the base and the hydrogen here. This is a neutralization reaction, isn't it? Anybody remember products of neutralization reaction? A salt and water. Remember we talked about that. So this is your salt now. It's a funky looking salt. It's not sodium chloride. It is sodium methanoate. My carboxylic acid lost its hydrogen and now has sodium on it. Down here, benzoic acid loses its hydrogen to the OH and now puts potassium here. Potassium benzoate is what that is. You may see if you look at your labels, this is a common food preservative. Think that's good for you? There's a whole bunch of people in the world that are opposed to food preservatives. I think they're kind of crazy myself. We need food preservatives. Do you think potassium benzoate might be good for you? What's the other functional group that's in potassium benzoate besides the carboxylic acid? The benzene ring. It's an aromatic compound, isn't it? It's an aromatic ring. Did we talk about aromatic rings and what they do? They are what? They cause something. What do they cause? What do aromatic rings do? They are carcinogenic. Do they cause cancer? We talked about that, right? Because that aromatic ring will fit into your DNA structure and cause mutations in it, potentially causing cancers. Okay? So a lot of people don't like the idea of using benzoates in their food. Here are a couple of other ones. We have sodium benzoate, same as potassium benzoate. And there's some people's favorite one on the right. What do we call the one on the right over there? Who likes Chinese food? MSG, monosodium glutamate. It is a dual carboxylic acid, isn't it? It's got carboxylic acids on both ends of it, except only one of them has been deprotonated, replaced with a sodium. That's why it's monosodium. If you replace it on this end, it would be disodium, right? Now these salts are like most salts. They have high melting points. They tend to be soluble in water, and they're solids at room temperature. Means that they act a lot different than their counterparts that are just carboxylic acids, right? Because most carboxylic acids are liquids or even gases at room temperature. Okay. These carboxylic acids are used as the salts of these carboxylic acids are used as preservatives and flavor enhancers, and we all know about them, right? A lot of people don't like MSG. They say it gives them headaches or they're allergic to it and all that kind of stuff. But it's pervasive. It's in a lot of stuff. So read your labels and you can find all this stuff. This isn't on the shampoo bottle now. This is in your food, right? Okay. This. Here's a reaction of propanoic acid with sodium hydroxide. Look what's happening here. You can even go back as far as remembering this is a double replacement reaction. This hydrogen goes with the hydroxide, and that means the sodium is going to come over here. So now we have this attraction here because it's an ionic compound. This is the salt plus water. These are the products of a neutralization reaction, right? So we've seen this before. Right? Okay. Now, carboxylic acids are part of the metabolic process. For example, when you undergo glycolysis, glucose is broken down into 2 molecules of pyruvate. Pyruvate is a carboxylic acid. Now, when you have low oxygen levels, this pyruvate is converted into lactic acid. And what happens when you have lactic acid in your muscles? They get sore. And that triggers your body to do what? Stop exercising because you're not getting enough oxygen. Okay? This is under anaerobic conditions. Don't have enough oxygen. Okay? Your muscles get sore. When you do have enough oxygen, these carboxylic acids go through the citric acid cycle, and you actually produce carbon dioxide. Okay? Citric acid cycle is just cleaving off carbon dioxides off of this molecule. And it cleaves off one every time you go around and releases energy. Okay? We're not going to get far enough to talk about citric acid cycle in this class. We won't get there. However, you should be able to look at these things and think about it. Look at the difference as you go across. We are oxidizing this molecule at each step. That O over the arrow means what? Oxidizing. When we oxidize something, what do? We add carbon-oxygen bonds. Okay? Now, it's not or, we remove hydrogens. So here, we removed 2 hydrogens, and we went from an alkane here, we made an alkene. We lost hydrogen, so it's being oxidized. Now, it should be pretty obvious to go to here that this is another oxidation. How do you recognize that as an oxidation? Because there's this. What did we do to go from here to here? What's the name of that reaction? Hydration. It's a hydration reaction. How do you know it's a hydration? Because this carbon here added a hydrogen, didn't it? And this carbon here added an OH. We hydrated this molecule. We learned that in chapter 12, right? Where we did hydrations of alkenes. Because this isn't new. And then this alcohol further can get oxidized. What kind of molecule is this now? According to this right here, what's this functional group right here? That's a carbonyl carbon. So what does that make this molecule? It is a ketone. Carbonyl carbons, when they're on the end of the molecule, are aldehydes, right? It's not on the end of the molecule, it's in the middle. Therefore, it's a ketone. You guys should recognize what's going on here at each step. This is not new. We have done this before. All right, so that's carboxylic acids. What about esters? Anybody ever used any esters before? I think I told you maybe I did. I was down at my parents' house at Christmas time, and my sister-in-law had gone through my mom's old photo albums. Found some pictures of some esters from the 70s. Was my family a bunch of chemists? What did people wear in the 70s? What fabric? Polyester. The terrible twins, polyester. Lime green leisure suits. She found a family picture. My mom had a lime green leisure suit. I had a burgundy polyester jacket. It was just hideous. It was bad.
So was your sister punishing you or raising?
My sister-in-law. I don't know what the heck she was doing. Well, what are esters? We're going to get there to talk about esters, okay? One of the first esters that people discovered was salicin, and it's made from, they isolate it from willow trees. Your body converts salicin to salicylic acid, and it can irritate your stomach line. However, Mr. Bayer, who was a German chemist, discovered how to turn that ester into salicylic acid. That salicylic acid into acetyl salicylic acid, and acetyl salicylic acid is known as, what's acetyl salicylic acid? What does Bayer do? Where do you see Bayer? Aspirin. Bayer aspirin, the very first people to make aspirin.
It's in like face wash and it's like peroxide.
Yeah.
That's
Salicylic acid is in some, they also have it in some oh my God, acne medications.
And people used to take that.
Well, you still do. I take aspirin sometimes. It's one of the first NSAIDs, right? Non-steroidal anti-inflammatory drugs. Aspirin is very common. It's also used to help lower blood pressure and stuff. Yep. So acetyl salicylic acid is an ester. Let me show what it is. An ester really looks like, if this is a carboxylic acid, look right here. We replace that hydrogen with what? With a carbon, okay? So it has a carbonyl carbon, and now that oxygen, instead of being a hydroxyl, is now, looks a lot like an ether, doesn't it? If I covered this up, remember last week we talked about ethers? Oxygen between two carbons? Well, now one of the carbons is a carbonyl carbon. This is an ester. See, I can't forget what we did last week. I know we're getting towards the end. Just gotta remember what we've been doing, okay? Esters are responsible for aromas and flavors in certain fruits. I went and picked strawberries this weekend.
Were they good? Must have been fun.
Yeah, they were good. So, esterification. This reaction is the production of an ester. Let's look at this reaction. If we take an alcohol and we take this OH like that, what do we get from this OH plus H? We get water. So then what happens? This oxygen joins onto this carbon right here. So it's called an esterification reaction, where this oxygen actually bonds onto this carbon and we lose this water, and now look. This is an ester molecule, okay? Because it looks like an ether with the oxygen between two carbons, but one of the carbons is also a carbonyl carbon, okay?
So, quick question. By carbonyl carbon,
This
is that terming the CH3 molecule?
No,
Not
this is
these?
carbonyl.
Okay.
CH3 is methyl.
Okay.
Carbonyl is C double bond O, right?
Okay.
You gotta remember your terminology. Carbonyl group, right? Okay, here's another example of esterification. Here we have, we're gonna lose that, and this is gonna come in right here. So, we have two carbons on the left, and then we have three carbons on the right from these carbons here, right? So all we've done is we've lost some water, and this oxygen comes in. This is called esterification. This is how they make, this is actually how they make biodiesel. They esterifize things, okay? We're not going to worry about naming